Okay, so in this new video, we will discuss one scenario to troubleshoot, and in the next video, I'm going to cover one more scenario to troubleshoot, and I'm going to give you some steps on how to approach a certain problem. Okay, and for this one, we will cover something which is very common in the Wi-Fi world, and it's seen very commonly and in pretty much all the networks. That is clients facing slowness in the Wi-Fi, right? Every network has complained about this, every customer has complained about this. Okay, so now whenever you run into a problem, no matter how big it is, we need to narrow it down. Okay, I know as if you're a network admin, or if you're a WLAN admin, the expectation would be that you need to just come and solve the issue in no time, and that's not how really things work in the on the ground. Wi-Fi being a little complicated than wired, you will take some time to narrow the issue down. So there's no harm in asking questions from the people, from the users on the ground. There's no harm in asking as many questions as you want. Get as much information as you possibly can, and then try to narrow down the issue, and that's going to give you the right approach. Okay, so just to save you enough time on the ground and effort, I'm going to give you some reasons as to why this could be happening. So the next time you run into a problem of clients facing slowness, you know what to do, how to approach the issue, right? So let's discuss as to what could be the problems with this. So when my client is facing slowness in the network, the number one problem could be that the client is very far from the AP, right? What will this do? If the client is very far from the AP, then I'm probably guessing it's going to be connected on low SNR, right? It's going to be getting a low RSSI value signal from the AP, right? It also will be on a low data rate, right? So check for these things. I mean, this is probably something that you have to look initially when you see someone complaining of slowness in their network. So check if they have a low SNR. This you can get in the client insights. This you can get in the client settings when the client is connected. Mostly vendors show this. So it doesn't matter on which vendor you are. Every vendor should be able to show you the client's settings and the client stats in their dashboard. So you should be good. The second reason that could be possibly interfering with the slowness of our network or the clients, is that it is possible that there are more clients on the AP than they should be. Okay, now when I say this, I want to go back to the point where I said for data, do not have more than 40 clients. For voice approximately 20, and for video also approximately 20 clients. Anything beyond this, the bandwidth, we know it's going to be shared between the users on the AP. So you do expect, if there are some bandwidth intensive applications that these guys are running, you are basically splitting the bandwidth of the access point among these clients, and that's always not good news if you have more clients on the access point. So just check. It could be because there are more clients on that AP than there should be, and maybe the nearby AP is not working, or for whatever reason, there are generally there's high density in their environment. So these things need to be checked. So this is how you're going to approach the issue, right? You got to know this. One more thing, let's say my AP is connected on channel number 11 on 2.4, or let's say channel number 44 on 5 gigahertz. Okay, anything. Now it is possible that my channel could be overutilized. It could be because of multiple reasons, like Wi-Fi interference on the channel. Okay, it could be because of non-Wi-Fi interference as well on the channel. So only Wi-Fi interference doesn't really cause the overutilization to happen. It could be non-Wi-Fi interference also that could be caused. So for this, get a spectrum analysis done. Okay, this is going to check for non-Wi-Fi interference. Now ideally, the channel, when I say channel number 11 and channel number 44 being overutilized, I basically mean that frequency band that we have of channel number 11 to send traffic, there are already some other things on that channel that are utilizing the channel to, to a maximum of, let's say, around, I mean, ideally, I want to have my channel as free as possible, but anything beyond 50% is something which will raise an alarm for me on 2.4, and same on 5. So ideally, we should not have more than 50% utilization on the channel. Anything beyond this, I've seen clients suffer. I've seen clients run into speed issues and throughput issues and performance issues. Anything more than this, so check for the utilization. Most vendors do provide this in their dashboards. Then they also can tell you if it's a Wi-Fi interference or a non-Wi-Fi interference. Wi-Fi interference could be because of the other radios on that same channel around you, or the client's radios around you. Non-Wi-Fi could be anything which is non-Wi-Fi, right? Like, let's say a cordless phone or a Bluetooth or whatever. So yeah, I mean, this is another reason why, very, very common reason why you can expect the slowness in the on the client. And 2.4 being anyway, you don't have a lot of bandwidth to send traffic, so usually 2.4 gigahertz band has a lot of channels that are overutilized anyway, right? So you don't want to do that. So you just want to make sure that yes, you check this and then take appropriate measures, right? So the next place to look at is, because let's say my customer wants the client to get a lot of throughput, but my client is an old client, okay, which only supports 802.11a protocol or B protocol or G protocol. It doesn't support .11n, okay, it doesn't support .11n AC or AX. Now my customer is waiting for the client to receive a massive throughput, which usually would get on AC or .11n, but my client is an old client, so it's possible that the client doesn't even have the capability to extract the right throughput from the access point, right? It's quite possible that we're looking for something that your device is not even capable of. So that is something which you need to understand, and this usually is also possible in networks which are very old deployed, in very old deployed networks where the infra has not changed for a while, okay. Capability issue of the client, okay. In networks which are very old, deployed long back, and the laptops have not changed, the devices have not changed, you're pretty much looking at something like this. Now if you do go for an automatic refresh, the laptops have not changed, but now you're bringing in new APs, okay. So the APs are new, APs support AX and AC, but your laptops are pretty old, they only support ABG, so they're only going to extract that much. The other thing is that my client is a 2x2 AP, 2x2 client, okay, 2 transmissions, 2 receiving antennas that they have. Now an AP is 4x4, you want the client to extract that much throughput, or my client is 1x1, let's say, for example, my mobile phones mostly they are 1x1, and I'm looking to get throughput which a 3x3 client would get or a 4x4 client would get. That's something which I need to be aware of, and educate the customer that your client is not capable of extracting that much from the access point. So take a look at that as well without a miss, right? Similarly, I mean, just like this point, an AP could be an old AP, right? An old AP is installed. Now this network was deployed long back, all of a sudden my APs only support 802.11a B, G. Now all of a sudden the boss brings in a new mobile phone or a new laptop or a MacBook Pro that supports .11ax. It's a 4x4 laptop, and now he gets only up to 54 Mbps because he's connecting on .11a now or .11g. Now that's going to be a concern for the boss because he's just got a brand new MacBook but only receiving 54 Mbps, and that's going to raise an alarm. He's going to come at you and shout at you, but you need to educate him that your AP is not capable of giving that much out to the client. Just like in the last D point, the client was not capable, here the AP is not capable. So you might just want to go for a refresh and see, once you put a new AP, you should be able to get that thing going. Another very, very important thing to look at. Okay, so now for the next point, it's also possible that there's only one client complaining, okay? It could be a client specific issue or a vendor specific issue. When I say vendor, I'll tell you what I mean. Let's say there's only one client sitting at the corner okay, and always raising a ticket to me, and I'm the IT support guy, and he's always raising a ticket to me and saying that it's not working fine for him, or there's too much slowness in the network, or there is one set of laptops that are complaining. That's what I mean by vendor. Okay, let's say I have a bunch of old Dell laptops, which are, pretty much everyone is facing the issues in that, and I want to really check if the drivers got updated or not. That's what I want to check, right? It's a client specific issue, or it's a vendor specific issue, whether it's just a bunch of laptops of the same make, or it's a specific client sitting right at the corner. I need to isolate that and check that as well, right? Or for when I say I just want to cover two more points in this, it could be a location specific issue. Okay, which means only in one boardroom people see this kind of an issue. The AP could be faulty, or whatever the reason is. It's only in that one single boardroom that you face an issue, or only in the cafeteria during peak hours you face this issue. Then probably there are more clients on the AP than there should be. Just try to isolate that as well. Understand where the issue is going on really on the ground. It could also be an AP specific issue. Why not, right? AP specific issue. Sometimes the radios do go bad. Sometimes the AP is not performing as well as it should. So you need to check that as well. Just check with a bunch of people on the floor whether they are facing an issue or not. If only clients near one APs are complaining, then you know what the problem could be, right? At least it's going to point you in the right direction. It could also be an SSID specific issue, right? Only on a specific SSID the clients are facing some sort of an issue on slowness. Maybe you have enabled rate limiting. Maybe you might want to check rate limiting. Somebody might have enabled that by mistake. Why not go and check that? These are all very common things that people miss out initially, because especially when a new admin is in place, he doesn't have much experience, so he doesn't know how to approach a problem. He doesn't know where to look. So that's when confusion can happen, and that's when a lot of time can be wasted, right? So anyway, after that, what you can check is there's something called channel bonding. Okay, when you bond two channels together on 5 gigahertz, on 2.4 don't do that. It's not going to work. On 5 gigahertz, let's say you bond channels. The channel bonding which we have are 20, 40 megahertz, 80 megahertz, and 160 megahertz. Okay, here you bond two channels together, here you bond four channels together, here you bond 8 channels together. Now by default the channel width will be 20 megahertz. This is the default setting in all the vendors. Okay, now if you are facing slowness, it's okay to try to change it to 40 megahertz. Just make sure you have enough channels to have a non-overlapping design done. Okay, I would not go to 4. I don't want to do that. I don't want to go to 8 at all. So maximum go to 40. I usually keep it to 20, and I try to do other things around it, and mostly I'm able to figure out why there is slowness. But this is one option that you can take. Try to increase the channel width to 40. More the width, more clients more data can be sent across, and basically you're just doubling the size of the channel. Means you've got a highway of 20 megahertz, and you've got cars going here in the highway. Suddenly you increase the width to 40 megahertz, double the highway size. Okay, now the number of the data which is sent is doubled. Okay, so you're basically virtually doubling the throughput just by increasing the channel width to 40. But it's not a very smart idea in every network. Try not to do this in very dense networks. Okay, I've seen networks deploying 160 megahertz also, which is an absolute sin in the Wi-Fi world. Why? Because in 5 gigahertz you've got 24 channels if you are using pretty much every channel. Okay, now when you have DFS enabled, you remove some channels from there, and now 160 megahertz mean even with 24 channels available, you make one channel out of 8 channels. So you using only 3 channels, which is as good as 1611 in a way, it's like 2.4. You got 3 channels now. So I would never do that. Now imagine in a dense environment using 3 channels is not going to work. Similarly, don't go for 4 also, 80 megahertz also. What I do is I usually keep it to 20 megahertz, which is more than enough. Okay, give the network enough channels to work, that's going to give you more benefit in the long run than some speed in the short run. So give the channel give the network more channels to work with. With 20 megahertz you have all 24 channels available, and they're all non-overlapping. So do this. Do not go for the approach of 160 megahertz, 80 megahertz. 40 is still okay. We can try that. Okay. Now another possible reason could be that, and with the transformation in the Wi-Fi world happening now, what we do is we have around .11ax access points deployed in most networks, and some of them already have AC and some of them have moved to AX now. But people coming from the older infrastructure, they had switches deployed, and then they had the APs connected to the switches. The APs initially used to take 15.5 watt of power to power up. These are .11n APs, .11abg APs. Now with .11ax coming in the picture, they require 25.5 watt of power. Okay, the customers buy the APs, that's all good, fantastic, but they forget about the capability of the switch on which the AP is connected. Maybe the switch is only capable of sending out 15.5 watt. Now when the AX AP gets connected to an old switch and gets 15.5 watt of power, it does power up. Absolutely, it will power up. Okay, but the problem with that is a 4x4 AP will fall to 2x2 or sometimes 1x1, which means you are reducing the effective capability of the AP with not giving it enough power. I've also seen the APs misbehave sometimes when enough power is not given to them. This is not the only thing that happens. It falls to 2x2. The APs also can misbehave sometimes. So the first thing you check when you sell something to the customer, or you come later on into the network and you understand what's going on, check if the switch is giving out enough power or not. Some of the vendors highlight this in their dashboards that the AP is not getting enough power. Some vendors do not. You need to probably check the power budget of the switch on the CLI or on the dashboard and check if they're giving out enough power or not. I've seen APs working on it's a good network, everything is fantastic, but the APs are falling on 2x2 because the switches are old, and then you have a 4x4 client or a 3x3 client or many clients on the access point. They're not even able to serve the clients properly because the capability has fallen to 2x2. So very, very serious concern this is, and I think if you look at all these points to troubleshoot a slowness issue, I think you should be pretty very near to solving the issue and understanding at least what's going on. So do these steps. And also, in case you need more help around some troubleshooting scenarios, reach out to me on LinkedIn. Okay, my LinkedIn is open for all of you. Drop me a message, tell me what's going on. Maybe we can get on a call and we can discuss as to what should be the next steps. If you get stuck somewhere, I'm here to help you out. And just don't feel that you're going to be bothering me too much. Just drop me a message without even thinking, and I will give you guys, and I'll respond to that. Hopefully we can get on a call someday and then discuss if there's anything specific going on that you might need help with. Okay, cool. So in the next video I will cover another scenario, so hang on. Thank you very much.